Hi everyone, we're going to find the solution set for each polynomial. This is part 6 and this is the 3 problems we're going to do. So the first one is x plus 2 times x squared minus x plus 1 is positive. So our solutions are just basically x equals negative 2, or you could say negative 2 comma 0. This has no real solutions, and it only has complex solutions. So we're going to go to our interval, and it's x equals negative 2. So what we want to do is check from negative infinity to negative 2, and then from negative 2 to infinity. And we choose numbers, so I just choose the ones kind of close. And I always choose 0 if I can, because that makes it easier. And again, our f actually is x plus 2 times x squared minus x plus 1. So when you plug these in, I'm going to plug in negative 3, and I get negative 13. And when I plug in 0, I get 2. Well, negative 13 is a negative number, and 2 is a positive number. And we want this to be positive, so we're picking this interval. Therefore, our solution set is x, such that x is greater than negative 2. This is what would be x is greater than negative 2. Okay, the next one we have, let's see. This one, it has 3 parts. X plus 1 times x plus 2 times x plus 3 is negative. So our solution set here is negative 1, this one is negative 2, and this one's negative 3. Or you can write your intercepts like this. And those are what we're going to use our intervals. So we have our intervals here. And I'm going to write my numbers smallest to least. So this would be negative 3, x equals negative 2, x equals negative 1. So we're going to start with negative infinity to negative 3. And then we're going to go from negative 3 to negative 2. See what's going on between those two. And then from negative 2 to negative 1. And then we're going to use the last one, negative 1 to infinity. Everything bigger than negative 1. And our function again was f of x equals x plus 1 times x plus 2 times x plus 3. And we want this to be negative. So we're going to choose numbers in all these intervals. And the ones I chose were negative 4, negative 2.5, negative 1.5, and 0. And when you plug it in, you're going to get, and you plug it into your f here, you're going to get negative 6, 0.375, negative 0.375, and 6. So the only two negatives we have are here, that's negative, and this one. So those are the intervals we're going to choose. These both are positive numbers. Now, I'm going to do my solution set, and the only ones we want to pick are this one and this one, or here and here. So my solution set is x, such that x is less than negative 3, or x is in between negative 2 and negative 1. Okay, and the last one we have is here. This one is going to be x cubed plus 2x squared minus 3x is greater than or equal to 0. So that just means we want positive values, and they can also equal 0. And I'm going to factor this. You get x squared plus 2x minus 3. And this part's easy to factor. This would be x plus 3, x minus 1. So also remember, this is really x minus 0 here for this one. So our zeros are 0, negative 3, and 1. Those are your x-intercepts. So I'm going to write them down again, but from least to greatest. So we have x is negative 3, x is 0, and 1. So the intervals I'm going to choose for this one will be negative 3 to infinity, then from negative 3 to 0, then from 0 to 1, and then from 1 to infinity. Okay, and then you just choose numbers in between these values, these intervals, and the ones I chose were negative 4, negative 1, negative 1/2, and 2. And then you plug it in your function. Our function happens to be f of x equals x times x minus 3 times x minus 1. That's plus 3, sorry. All right, and we want all positive values, and it can equal 0. So when I plug it in, I got negative 20 for negative 0.875 and 10. So the only two positive numbers we have are 4 and 10. These other two are negative, but we want positive. So our solution set's going to be, we're going to pick this one and this one. So it's x, such that x is, for this one, it will be, x is in between, and you can equal it because there's an equal sign here. Negative 3 to 0, or, and we take this one, this will be x is greater than or equal to 1. And that's all. Thank you. Have a nice day. Bye-bye.